So here we have an empirical formula problem. The bottom line is that in an empirical formula problem, what you're trying to do is get to the mole ratio of each of the elements that are present in the compound that you're analyzing. In this case, we're starting with percentages. So it's a pretty easy, easy route to get to moles of each element. If we assume we have 100 grams of the sample, using the percentages, then I can write down that I have 48.10 grams of carbon. I will have 9.33 grams of hydrogen and 42.57 grams of oxygen. And then, kind of, knowing ahead of time the flow of this, I'm going to go from grams to moles. So I'll use my periodic table and say that there's 12.01 grams of carbon for every 1 mole of carbon. So this is going to get me into my moles of each element. Hydrogen 1.008 grams to 1 mole of hydrogen, and the oxygen 16.00 grams of oxygen to 1 mole of oxygen. So we'll go ahead and figure out the moles of these. All right, so we've done the calculation to figure out the moles of each of these. Now, if we remember that ultimately what we're trying to do is we've got carbon, hydrogen, and oxygen. We're trying to figure out what subscripts are going to go in the formula for that empirical formula for those 3 things. So we need the mole ratio of this. We can't put decimal numbers in there. They have to be whole numbers. So we're going to have to do something with these mole numbers that we got here. And so the first step, again, this is just a procedural thing. This isn't something where you create it yourself. You always divide by the smallest number of moles. So we're going to divide all of these by the moles of oxygen. So it's 2.66. And then that'll give us a new ratio of moles. All right, so here I've calculated out the new mole ratios. Notice I've tried to keep all the decimal places here. They don't come out. They still don't come out to whole numbers, but at this point I should be able to eyeball what I need to do next. And so obviously the oxygen came out to 1.00, so we divided it by itself. So to make the carbon and the hydrogen come out better, we're going to have to multiply by 2. And so we're going to move down here a little bit. And after I multiply by 2, I will end up with, what would that be, 3.00, sorry, 3.010 moles of carbon. We'll have, what's that going to come to? 6.96 moles of hydrogen, 2.00 moles of oxygen. And at this point, we can go ahead and round now. So we would have our formula C3H7O2 for the empirical formula for, I believe we have propanoic acid.